Okay, so in this video, we're going to be factoring polynomials where the GCF happens to be a binomial factor. Okay, so we just learned how to factor using a greatest common factor, and most of the time, you're going to have a monomial factor that's the GCF, but there are going to be occasions where the common factor, like x minus 3 here, okay, is the GCF. It's what both of these terms have in common. So you want to think of this 4x times x minus 3. That's one term. This 3 times x minus 3 is another term. So they have that x minus 3 in common. So in this case, that x minus 3 is the common factor. It happens to be a binomial factor, okay? But the process doesn't change, okay? So my GCF is x minus 3. So what I want to do is I want to divide this by x minus 3. So these are going to cancel out. So what's left is 4x. Then I'm going to divide this by x minus 3. And what's left is the 3. Okay? So what's left over is this term, 4x, and this term, plus 3. Okay? So when I factor this, I'm going to get x minus 3 as my common factor. Happens to be a binomial. And what's left over is the sum, 4x plus 3. And I'm going to write that as a bi times a bi. Okay? This is the answer. There's nothing else we can do. You know, if I were to multiply these out and combine any like terms, and if I were to multiply this out and combine any like terms, I would get the same expression. Okay? This is really important going forward because one of the things we're going to do when we factor quadratic trinomials, we're going to have to use this method to factor those. It's the way we're going to introduce that to you. Okay? So, look at number 2. The greatest common factor is going to be that 2x minus 5. These match up, so I can divide each of these terms, this one and this one, by that 2x minus 5. Okay, so my GCF is 2x minus 5. Okay, so what's left over? If I divide this whole thing by 2x minus 5, what's left is 3x. If I divide this whole thing by 2x minus 5, what's left over is minus 1. So I'm left with 3x minus 1 as my second factor. Okay? Now, notice that in these, the binomials matched up. Okay? In 3, the binomials don't match up. Y minus 2 is not the same as y plus 2. Okay? So the binomials have to be the same. Because they're different here, there is no GCF. Okay? 4y and 3 don't have anything in common. These binomials don't have anything in common. So there is no GCF. Okay? So we're going to consider this expression to be prime, which means it can't be factored. Okay? And finally, number 4. One of the things you're going to see in the future is that we can factor this 9x squared minus 4. But for now, we're just focusing on the GCF. Okay, so x plus 2, they have the binomial in common. So that's my GCF. Okay? If I divide this term by that x plus 2, I'm left with 9x squared. If I divide this term by x plus 2, I'm left with minus 4. So my factors are x plus 2, 9x squared minus 4. Again, like I said before, in the future, this can be factored further. But for now, our focus is on finding the greatest common factor that is a binomial. Okay? So that's how you factor out an expression when the greatest common factor happens to be a binomial factor.